So this is the third video on drive axle assemblies, fundamentals, and service. So now we're going to look at different applications. So again, what do we want this differential for? Is it a day truck that just rides around town, doesn't have a lot of weight, or is it a heavy mover that requires differentials with, say, outboard planetaries so that they have extra gear reduction for hauling the weight? So with everything that we have to sacrifice something. So again, if we want a lot of torque, we don't get a lot of speed. Want a lot of speed, and we don't get a lot of torque. So we have to figure out what we want in the differential so we can spec it out. So again, you don't have to memorize this, but every manufacturer will have numbers on the side of the diff on a tag that will determine what that differential is, and also the gear ratio of it. So again, speccing out a vehicle for the weights we want to haul will determine what size differential we get. For instance, again, if I'm using to haul logs, I might want to try them with a low gear ratio if it's in the mountains. If it's on the flat, I may not need to have a gear ratio that's that high, so I don't have the pulling torque, but I can get the speed out of it. So again, different gear ratios will determine what we're going to get. For instance, if I have 8.7 to 1, means for every 8.17 turns of the drive shaft, I'm going to get one turn of the wheel. Or if we get down into this 3.54. Now, one of the things we talked about when we discussed gear ratios at the beginning is what is a hunting gear set, partial non-hunting, and partial hunting. So again, understand what those are. Now, if we take a look at it at a exploded view of a differential itself, understanding what all of these components do in the differential and how to inspect them or adjust them. So what we're going to look at now is different parts of the differential. Again, some of this will be reviewed because we've already seen some of these. So going through and taking a look at some different configurations that we might see in a differential and also in an interaxial differential. So for instance, if we take a look at the housing itself, is the housing straight? How much fluid is required in the housing? Does it have a temperature sensor? How do we inspect the axles? And again, we have to understand and know all of this so we can maintain these housings and these differentials properly so that we don't have failures. And again, when we're taking a look at the input of a differential, understanding how the pinion and crown gear are related, what all these components do, and how to inspect them properly and make sure that they last a long time. Now, we talked about amboid, hypoid, and center mount. So again, an amboid, one advantage of an amboid pinion set is it gives us a lot of ground clearance. So we could use this where we need the ground clearance. When we get into a hypoid, it's probably one of the most common that we're going to see because they handle a lot of load, but sacrifice is the ground clearance. And then we get into center mount, which you don't see much of, but they are out there. Now, earlier we talked about a thrust screw. And again, what does a thrust screw do and how do we adjust it? Well, you're going to have to look that up in a spec book because, again, it depends on the thread pitch of the thrust screw. So the thrust screw goes in, touches the crown gear, and you back it out. Let's just say that a quarter of a turn will back it out 30 thou. So again, we need to know what that specification is so we can get we don't want this crown gear deflecting too much. We have to make sure we adjust this thrust screw properly. Now, in one of the other videos, I talked about thrust block that they used to have on these. And again, they got rid of these because people would back the thrust screw out and the block would fall off down into the base and get picked up by the gear and take the gear out. So you might see some of these, but you might not see any more. Now, we talked about power flow through a differential, how it comes in through the pinion gear out to the crown gear to the case half, because again, case half's attached to the crown gear. Then power flow does go through the pinion gears and the side gears. If I took out one pinion gear, the machine wouldn't go anywhere because everything else would just spin internally. Well, what about a double reduction? So a double reduction is not a two-speed, it's a double reduction. So we have one reduction here with our crown and our pinion, and we have another reduction here. When we get into a two-speed, so we have a double reduction, but it is also a two-speed. So we have a single reduction here and a reduction here, or if this sliding collar is engaged in this tooth, this gives us our second reduction. The other thing we might see is planetary gear sets as a two-speed rear axle. And again, if you remember from when we were doing planetaries, if we engage a planetary, we can get a gear reduction. So when we take a look at how the case halves are set up, we still have our side pinions and we still have our side gears, but now we're going to have a planetary gear set to give us a gear reduction. And how this is set up is, here's our planet carrier, here's our internal ring, and here's our sun gear. So depending on how this is set up, this gives us low range, okay? And when we disengage this, sun gear is no longer locked. Now this gets to move. So that would be high range or direct. And then this would be low range. Now the other thing we want to look at is if we have a tandem drive, we have three differentials. We have two in the front and one in the back. And in the front we have what's called an interaxle differential. And it's in line with the axles. It's a normal differential. It does exactly the same thing. It's just in line. We can lock this differential so that we can lock this input yoke to this output yoke. So it means that the front differential is locked to the back differential. Doesn't mean that the wheels can't slip. It just means the amount of torque going to the front differential will be the same as the one going to the rear differential. And why is that an advantage? Well, if we have, let's say, one of our front wheels or one of our rear wheels on ice, because the axles are locked together, let's just say our right rear wheel is on ice and our front wheels are on dry ground. With the interaxle locked in, our front drive axle will pull the vehicle out. If we disconnect our interaxle differential and one wheel's on ice, nothing's going to go anywhere. All the torque goes to that one wheel that's spinning. Nothing goes to the other ones, if you remember what we talked about before. That's why an interaxle differential is so important. But the other thing is what we talked about is being able to lock our axles up on each axle itself, so that we really get a four-wheel drive. Now, our cover for our interaxle differential is a little different, it's a little bigger because it does carry a lot more components. So we're going to have our input pinion and our shaft, but these are going to drive different components. Our differential assembly case halves will be the same. We'll have a thrust washer, we'll have differential pinions, and we'll have side gears. Now, our drive gear, so off of our input, we're going to have a drive gear. And if you remember from helical cut gears, what types of forces do we get? Well, we get axial forces. So with those, we'll need thrust washers. Output shaft, again, depending on the application, how they're set up. But our output shaft, again, if you remember a normal differential, will have side gears. Well, these are in line, again, because we need them to go from the front axle to the back axle. Now, how do we lock it up or how do we engage it? Well, in most highway trucks, it's done by air. Air goes in, pushes down on a piston, and what it does is engages these teeth. And if we take a look at the setup, so if this is unlocked, power goes through here. Now the wheel with the least amount of grip is going to spin first. So this is what I was talking about. If this wheel here is on ice, these wheels here will not spin. We don't have a locker here, we don't have a locker here, and this locker is disengaged. Power flow would be through here out to this wheel. This wheel will spin and these will stay. If we engage this and lock this up, this wheel will spin, this one won't, but these two will drive that vehicle out until this wheel gets onto hard ground. Now the other thing we need to know is it a full floating or semi-floating axle? So in anything really over a 3/4 ton will be classified as a full floating. So let's take a look at a 1/2 ton. So a semi-floating axle, the axle shaft actually rides on a bearing inside the housing. What we want to look at is a full floating axle. In a full floating axle, our hub rides on the bearings. Our axle is bolted to our hub, so it doesn't take any of the load, radial loads, but it drives the hub. Now, another thing we want to take a look at is outboard planetaries. Outboard planetaries are there to give us another gear reduction. And if you remember when we were talking about what is the most common setup, well, the most common setup is our sun gear is our drive, our planet carrier is our output, and our ring gear or internal gear is held. It's part of the housing. So we took a look at a housing. So here's our ring gear or our internal gear, and this assembly is mounted solid. It does not spin. Sun gear is our input, and our planet carrier, which is bolted to our hub, which our wheels attached to, is our output. Now we can have a front wheel drive assembly, and again, it can be set up a little different. And again, if it is a four-wheel drive, again, we'll have a differential in the front housing, and it's going to drive these drive shafts, which will drive the front hub. Now, what about lubrication? Now, again, we talked about how important lubrication is in the vehicle to make sure that we get adequate lubrication to all the bearings. Now, most front diffs will have an oil pump in them, but rear diffs won't. They rely on splash lubrication to feed these bearings to make sure that they're fed properly. So if we have a gear pump assembly in the interaxle differential, we'll have a gear pump drive, and this will be a gear that's driven off of one of the internal gears inside. And what it will drive is it will drive a gear pump. Now, if remember, gear pumps are positive displacement pumps. And so some of the new ones now are bolted to the front, so if any repairs have to be done, they can be removed or inspected without having to disassemble the whole unit. We also have a magnetic screen. So this is on the suction side, so anything that comes through has to be pulled through. The magnetic screen will pick up any metal so it doesn't go through and damage our pump. The other thing we have is magnetic plugs, and this will not be a lower plug. This will be the upper plug. A lower plug will just have a magnet in here. Now, we talked about what a plug swap is. So if we pull this plug out and we find that there's a lot of shavings on here, and it's more than just fuzz, we want to take a look at it. And if we determine that, yeah, that's more than what we'd like, then we can do the plug swap. Anytime you pull these out to inspect them, clean them. Get rid of all the material that's on them so that the next person pulling it out doesn't go, oh, geez, there's a lot of material on that. The stuff you see might be from someone that left it over they just didn't clean it from the time before. The other thing we want to look at is a filter. A lot of these will have a filter on them, and one of the things you really have to pay attention to is the steel guard that's in front of the filter. If this is broken, you run the risk of puncturing this filter with a rock, and spreading all oil all over the underneath of the truck. These filters should be changed at regular intervals. I've seen some that were rusted right out. They hadn't been changed in years. It's part of regular maintenance. So when you're doing your servicing, change these at regular intervals so we don't end up with any issues. Now, how does a differential axle lock work? Well, we looked at an interaxle differential, which locks the front axle to the rear axle. But now we want to take a look at the locker that locks this axle to the case half. So when you pull the axle shaft out, you'll notice there'll be two sets of splines, one here, one here. This internal one is the same as this side. It locks into the side gear. But this one here, when this is engaged, will lock this into the case half. And again, if you remember, once this axle is locked in the case half, this side gear can't turn, so nothing else can turn in here. So both axles are locked together. Case to pay attention to is if you pull this axle out, be aware that this can fall down inside if you're not careful, and in some cases you have to remove the differential to get it out. So this is with it disengaged, and this is when it's engaged. Now, front and rears. So again, you have a switch on the dash that could run both together, or they can be separate. One of the things not to do, and why don't we want to weld our side gears to our pinion gears? Well, again, the side gears and the pinion gear allow the wheels to turn at different speeds when we go around a corner. So if this is locked solidly, again, the outer wheel has to turn at a greater rate than the inner one, and if it can't do that, it's going to scuff the tire along the ground. So we want to ensure that we maintain this. It's great for posi track and for doing burnouts, but it's not good for tire wear and internal component wear. And when things go bad, they go bad. So this is a failure of a differential. By taking a look at the components, you could probably determine how many spin outs he's done. So again, this is a major failure, and when this happens, let's say we blew up a diff in a highway truck, all the axles and bearings have to come out and they have to be cleaned and washed and inspected. Don't just pull the axles out, replace the diff, and put them back in. We want to make sure that none of these particles get in the outside bearings. That's the end of video number 3.